What is up, guys?
What's
Welcome
up,
to
guys?
Bill Ashman-Kaz's YouTube channel.
We're here for a physics demonstration today. I'll let Dr. Bill take it away.
Okay, so this red coil has a wire that loops around several times. So you're going to see the magnetic moment formula is N times current times area. So the N is how many times the wire loops around. With this one, the wire insulation is stripped off all around, so it's like conducting all around. So the result is that there's one kind of stable equilibrium. I guess that was it. If I turn the magnet around, I have to pinch the wires here to make sure that there's current flowing through the circuit. Yeah, if I turn this around, you can see that the stable equilibrium flips by 180 degrees. So one way to look at that is that a north pole and a south pole attract each other, and two north poles repel or two south poles repel. It's kind of the easy way to look at that. Okay, so you're not going to be able to make a motor out of this, because if it spins halfway around, then instead of having like a north pole facing a south pole, you're going to have like a north pole and a north pole. Actually, it's actually a little better to look at it in terms of mu cross B, like the torque. But in any case, if you did the calculation part of today's worksheet, you're going to see that once you've rotated halfway, you basically need either to reverse the DC current or to reverse the magnetic field to keep it going. So here's our trick to keep it going instead. Well, actually, let me try one more thing. Hey, Vias, see if you can try to push it a little bit and see if you can feel the torque increase as you push it more.
Bios, can you feel the torque increase?
I think so. Oh.
Because I think it should be maximum torque when you're kind of 90 degrees away from that equilibrium position. Okay, all right. So now this one, the black one, has, I don't think you can see this, but it turns out, well, you can kind of see this is dark and this is light, but it's light on both sides here. So this one, the insulation is stripped off only one side of the wire, but not the other. So what that does is basically, once this thing is turned halfway, it's like it cuts off the current. So the current is only flowing for one half of the rotation. So let's see what we can do there. So I think we want to straighten this out a little bit. I'm not going to edit this video, by the way, so it's going to have some boring spots. Sometimes I go all out and edit. All right. So
What if we make it into a YouTube short?
really? Well, you could do that.
Jason got you.
Okay. Oh, here we go. So you see, now it's turning, and it's turning pretty fast. And it's turning in such a way, I think, that the top part is going away from me and the bottom part is going toward me. Now, I think if I flip this bar magnet around, the way it's willing to turn is going to be the other way. So if I try to turn it that same way, it's not going to work. But it's going to turn the other way. So you see, now the top part is coming toward me, the bottom part is going away from me. And I'll flip the bar magnet around again. See, and now it turns the other way, where the top part is going away from me, the bottom part is going toward me. So you can think about that. See if you can kind of understand that based on what's in the worksheet. And here, let me just give this thing a little tap. So there's a little bit, one thing is a little bit of friction, but actually I think more importantly is this thing isn't centered properly, so there's like a little bit of a gravitational offset until you, so you have to kind of get it going enough that you overcome that. Let's see. I'll give it a little bump. Yeah. So then it keeps going. Yeah, and again, I think it's kind of neat that if you reverse the bar magnet, then the direction that it wants to rotate reverses. Okay. And you want to think about how it is that stripping the insulation off of one half of the wire and not the other half. What I mean is okay, so this wire, it's just stripped off the whole thing. But this wire, one half is covered in insulation and the other half is not, so that as you rotate around and around and around, the current is only flowing half of the time. So Ideally, you would actually reverse the current half the time, but that's kind of annoying to try to implement that. It requires this thing called a commutator. So instead, we just have the partially stripped insulation so that the current is only flowing half the time. Okay, so Jason is telling me I'm already going over time here. So I'm just gonna make this thing spin like mad as a finale, and then we're gonna say we're good. Let's see, so. Oh, there we go. Look at that, look at that, look at that. It's going like mad. All right, there's gonna be a cut in this video.